Okay, so here we are at, let's see, section 1.5 for beginning algebra and UW Whitewater. We're going to talk about this prime factorization in this video, prime factorization. So we talked about factorization. What is a factor? A factor is something that multiplies to get a product. So we got factors and products. Those are two words that we have to remember, factors and products. Factors multiply together to get a product. A product is, or has factors that divide evenly into that product. So there's factors and products. So we're going to go up here and we're going to talk about, we did these before. We're going to talk about prime factorization of a product. So we've got a product, a number, and we're going to talk about prime factorization. So if we're going to talk about prime factorization, I guess we better talk about what a prime number is. A number is prime, a prime number. If it's only factors, the numbers that multiply together to get it are 1 and itself, and that's it. So just like before when we had 11, 11 was 1 times 11, and that was it because no other factors came out of it. No other factors could multiply together to get to 11. So if we talk about prime numbers, that's what they are. Numbers divisible by only 1 and itself. So if we look for prime factorization is going to be helpful. Prime factorization is going to be helpful because that kind of tells us exactly what is inside, what kind of products or what kind of factors are inside of that product. So prime factorization tells us, I guess, is the expression of the number as a product of just prime factors. So we've got to find those prime factors and list them, and that's prime factorization. One method that I like to use is called the cake method. Let's see, the cake method was found by me in a book written by, gosh, I can't remember her name, but she was Winnie in the Wonder Years. So it kind of dates me, I guess. The cake method really is going to be helpful to find prime factors of some pretty big numbers. So if we got, we don't need to use the cake method, sorry, for finding things like what are the factors of 6, or let's find the prime factorization of 6, because it's pretty straightforward. But if we use 60 as an example, we can use 60, and we can say, you know what, here's 60. We're going to use the cake method for this. 60, let's find the prime factorization of 60. And we make kind of a divided by bar here, but it's kind of upside down. And we say, you know what, 60 is divisible by, and I guess I try to be logical. And I say, is it divisible by 2? Because 1 doesn't really help us. If it's divisible by 1, it's, we divide by 1 over here, and you get 60 down here. So let's see, is it divisible by 2? Yes, it is, because 0 is even. 0 means that the number is even, so we can say it's divisible by 2. Let's divide by 2. 60 divided by 2 gives me 30. And now we've got another layer of our cake. 30 is not prime yet. So we say, well, it's 30. Is 30 divisible by 2 again? Yes. Keep going by 2's and see if we can divide out of 2. Remember, we're looking for prime numbers over here, so go only the prime numbers. Prime numbers are 1. I suppose not 1. Sorry, 1 is not a prime number. We've got 2 and 3 and 5 and 7 and 9 is not. 11, dot, dot, dot. Those are the prime numbers. So we keep going with those. So we're starting with 2 and pull out as many 2's as we can. 30 divisible by 2, yes. 15. 15 divisible by 2, nope. Go to the next prime number, and that would be 3. 15 divisible by 3, yes. 3. 15 divided by 3, 5. When we get to a prime number down here, then all of these are our prime factors. And we could say this is prime factored as 2 times 2 times 3 times 5. And all we're doing is listing all of these factors. And that's the cake method of kind of writing out numbers in terms of prime numbers. And probably more officially, we'd say this would be 2 squared times 3 times 5. That would be our prime factorization of 60. So if we take a look at 156, well, 156, gosh, that's pretty big. So let's take a look at 156 and say, if we've got 156, let's see, I do have more room over here. So let's do 156 using the cake method. 156, start here. Our prime numbers are 2. We start with 2. Is 156 divided by 2? Yes, it is. We're going to find the prime factorization of 156. 156 divided by 2 is 7. Let's see, 26. Sorry, 8. Oh, 7. 14, 1, 6, 8 is what's left over. Pull out the 2 as a prime factor, and we get 78 left over. Is 78 divisible by 2? It still is, so we put another layer of the cake there. Divide by 2. 78 divided by 2 is 3, 9. Alright, divisible by 2? Not anymore. 9 is not even, so we put another layer of cake here and say, is it divisible by 3? 9 plus 3 is 12. It is divisible by 3, so put a 3 out here. I got 1, 3, and 13 is a prime number. So our prime factorization is 2 times 2 times 3 times 13. All those dots mean multiplication. I got 2 squared times 3 times 13. There's my prime factorization of 156. All those are prime factors of 156. If we go to the next one, well, that's what we did before. So apparently this is incorrect. Oops. I must have done something wrong when I created this. Apologize. Let's prime factor 260 and see if my factorization over here is correct. So 260, if we're going 260, we're going to look for prime factorization again. So we're going to start with 2 because 0 is even. So we're going to say 2 goes into it. I got 1 and 3 and 0. 260 divided by 2 is 130. Is it divisible by 2 still? Because we're looking for prime factors. We're going to pull out a 2 as many times as we can. 0 is even, so we can pull out a 2 in our next layer of the cake. 130 divided by 2 is, let's see, 65. Divisible by 2? Not anymore, because we got a 5 there. So now it is divisible. Let's see, is it divisible by 3? 6 plus 5 is 11. Nope, not divisible by 3. 11 is not divisible by 3, therefore 65, not divisible by 3. So then we go to the next prime and we say 5. Is it divisible by 5? Yes. That last number is 5 or 0, so it's divisible by 5. I've got a 1 and a 3. And there's my prime number there. 13 is a prime, so there, all this, 2 times 2 times 5 times 3, 2 times 2 times 5 times, times 13, is my factorization. So 2 times 2 times 5 times 13 is my prime factorization, which is right there. Probably better written right there. 2 squared times 5 times 13, and there's prime factorization. Use the cake method to pull out as many primes as you can of 2, and then 3, and then 5, and then 7, and see what you get left over when you get to a prime number down here. You're done.